Hi guys, Miss Powell here again. Today we're going to talk about measures of central tendency and variation. So continuing on with our stats unit, measures of central tendency and variation. All right, so let's look at the first slide here. The first slide says, example 1, finding measures of central tendency. So find the mean, median, and mode of the data. This is the number of deer at a feeder given every hour on the hour, right? So 3, 0, 2, 0, 1, 2, 4. To find the mean, what I want to do is I want to average all of these data values. The median is going to be the data value that falls right in the middle, and the mode is going to be the number that occurs the most number of times. Okay, now if you're thinking to yourself, didn't we already do this in Algebra 1? You're right, you did. This is not new information. However, I am going to go ahead and just briefly discuss with you how to input this information into your calculator. Before we do that though, what we want to do is we want to go ahead and rewrite this data so that it is in ascending order or descending, right? Either way will work. However, my default is always to put it into ascending order. So 0, 0. So I took care of those. 1, 2 2s, 3 and 4. Okay, so that's all my data in ascending order. If I want to figure out the mean of these, I'm going to add all of them together and then divide by the number of values that I have, right? So I have 4, 5, 6, 7 data values. 1, 2, 3, 4, 5, 6, 7 data values. So if I add all of these together, I get 3 plus 2 is 5, plus 3 is 8, plus 4 is 12. Okay, 12 divided by 7 is about 1.714285, etc. I'm going to round that to the nearest tenth, so it's about 1.7. My median is going to be the number that occurs right in the middle, right? So if I have 7 data values, I'm going to count over 4, 1, 2, 3, 4, and that's going to give me my median value. In this case is 2. My mode is the number or numbers that occur the most times, right? So I see that 0 occurs twice and 2 occurs twice. So my mode is actually 0 and 2. Now, if you wanted to use your calculator to figure out the mean and the median, you can, and I'm going to tell you how to do that. Once again, I took a screenshot of my keystrokes into my calculator and have displayed it here. So if you're having a hard time following along with me verbally, you can, of course, refer back to the keystrokes. All right, so the first thing that we want to do is hit your stat button. Hit enter. And what that does is it pulls up L1, L2, L3, L4, L5, etc. Right? So what these is a place for us to put in a list of numbers, right? So list 1, list 2, etc. So we're going to go up to list 1. So arrow up, hit clear, and then down. And then we can put in our values, right? So 3, enter, 0, enter, 2, enter, 0, enter, 1, enter, 2, enter, 4, enter. Okay, so we have all 7 of our data values entered in here. Then we're going to hit stat, arrow over to calc, and then hit enter. Hit enter 3 times, and that's going to pull up all of your stats, right? So you see all the data that I have here on the screen. Okay, you see all of this data. Well, obviously, X bar, we've talked about that before. That is actually your mean, and we do see that our mean here is about 1.7 when we round it, so that's good news. If you're thinking, Miss Powell, I don't see median, I know you don't, arrow down, and you'll see it. What's your median? Your median is 2, right? That's noted above. Your mode is not going to show up on this chart. That's all right. Once you rewrite your data values, you can easily pick out your mode or modes, plural, depending on if numbers are listed the same number of times. Or you can just look at your data values and figure that out. All right, so let's look at this next slide. This next slide, we want to talk about something called box and whisker plots. Once again, this is not necessarily new information, right? You saw box and whisker plots in Algebra 1, but we want to go over it briefly again. A box and whisker plot shows the spread of a data set. It displays 5 key points. And the key points are your minimum and maximum values, the median, and the first and third quartiles. These are called your 5-number summary numbers. Okay, so the 5-number summary. We want the minimum number and the values that we have listed. The Q1 value, your median, Q3, and your max. Okay, those are all super important values when we're talking about a box and whisker plot. The interquartile range, by the way, in case you have forgotten, it's just Q3 minus Q1. Okay, so Q3 minus Q1 is going to give us our interquartile range, and you will be asked to give that number at some point. So we want to plot the minimum number, the first quartile number, median, third quartile, and maximum. All of those values are actually able to be pulled up using the method that we just used on our calculator. And we'll go over that a little bit more with this next example. All right, so looking at this example, it says making a box and whisker plot and finding the interquartile range. So make a box and whisker plot of the data. Find the interquartile range. So this is our data here. We're going to go ahead and input this data into the calculator. All right, so inputting this data into the calculator, we have, first of all, I'm going to clear out my calculator. I'm going to go to Stat, press Enter, arrow up, clear out what's in L1 and go back down so that you can enter data. So I'm going to enter 6, enter 8, enter 7, enter 5, enter 10, enter 6, enter 9, enter 8, enter 4, enter. Okay, don't forget after that last data value to make sure that you hit enter. If not, it could give you problems on pulling up your summary that you need. So now I'm going to hit my Stat button. I'm going to arrow over to Calc and hit Enter. I'm going to hit Enter 3 times. And that pulls up all of my data values. So what is my minimum value here? My minimum X value that I see is 4. Okay, that is denoted by the min X. Okay, min X is 4. I want to know what is Q1. Well, Q1 is 5.5. My median, what is it? It is 7, right? If you arrow down, you'll see it. What's Q3? My Q3 is 8.5. My maximum value, once again, arrowing down, is 10. And my IQR, which was my interquartile range, I'm going to find by taking Q3 minus Q1. Okay, Q3 minus Q1. So Q3 is 8.5 minus Q1 is 5.5, which yields 3. All right, so if you need a little bit, so now let's go ahead and plot this stuff, and then I'll talk about something else. All right, so the first thing that I want to plot is my median. Okay, my median is located at 7. I'm going to put that value right here. So I've arranged these so that I can actually go up by increments of 0.5. Okay, so 7, 7.5, 8, 8.5, 9, 9.5. Down here, 6.5, 6, 5.5, 5, 4.5. All right, so I'm going to go ahead and plot these values. My minimum value is 4. Oops, and I forgot. I should have extended out a little bit further. Sorry, guys. This is 4. Okay. So I'm going to plot that point there on 4. My Q1 is 5.5, so I'm going to go ahead and plot that point right here. My median is 7, so I'm going to plot that point here. My Q3 is 8.5, so I'm going to plot my point here. My max is 10, so once again, I'm going to extend out a little bit further and hit my 10 right there. My interquartile range is 3, but we're not going to actually graph that right now. So to make our whiskers here, we're going to connect these 2 points here and these 2 points here. These two get boxed up around our median. Okay, and now what this actually tells us, in case you need a quick refresher, is that, I'm going to change colors here real quick, is that 25% of our data occurs here. Another 25% of our data is going to lie there, while 50% of the data is going to lie within that boxed in zone. Okay, so that's a little refresher from Algebra 1 in case you have forgotten what the box and whisker plots actually mean. All right, so let's talk about more measures of central tendency and variation. So if we have these two data sets of 19, 20, 21 and 0, 20, and 40, what's interesting is that they have the same mean as well as the same median, but these sets are very different from one another. The way that the data are spread out from the mean or the median is important when we talk about statistics. Okay, so we have a couple measures of variation that we want to discuss. A measure of variation is a value that describes the spread of a data set. The most commonly used measures of variation are the range, the interquartile range, the variance, and the standard deviation. The variance is denoted by sigma squared, and it's the average of the squared differences from the mean. The standard deviation, noted by sigma, right, that's baby sigma by the way, is the square root of the variance and is one of the most common and useful measures of variation. So a couple of things that we can look at here is if we have a low standard deviation, that indicates with the data that are clustered near the measures of central tendency, right? So what are the measures of central tendency? The mean, the median, and the mode, right? So if our standard deviation is low, that means that our data is right around these values, right? Clustered around the mean, median, and mode. If we have a high standard deviation, then that's going to tell us that our data are spread out from the center, right? So it's not going to be nice and tight within our center, but we're going to have a large spread in our data values. All right, so example number 5, we want to find the mean and the standard deviation. So find the mean and the standard deviation for the data set of the number of people getting on and off a bus for several stops. All right, so looking at this, we want to hit clear, stat, enter, go up, we want to clear out your L1, and then we want to go ahead and start building our list. So input 6, enter, 8, enter, 7, enter. 5, enter, 10, enter, 6, enter, 7, enter, 9, enter, 8, enter, 4, enter. And then we want to go back, hit your stat button over to calc and hit enter. How many times did I say? 4 times. And when you do that, what you end up seeing is that you're able to locate the mean, right? And our mean here is X bar. Our mean is about 7, okay? And we also want to note the standard deviation. So which one denotes standard deviation? Sigma X is going to give you your standard deviation. In this case, that's 1.7321. Okay, so standard deviation of about 1.7321. All right. Now let's talk about something called outliers. So what is an outlier? An outlier is an extreme value that is much less than or much greater than the other data values. So outliers have a strong effect on the mean and the standard deviation. If an outlier is the result of a measurement error or represents data from the wrong population, it is typically removed from the data that we've collected. There are different ways to determine whether a value is an outlier. One is to look for data values that are more than 3 standard deviations from the mean. This is best used when the data is normally distributed. Okay? And the second way is to consider our lower bound, our absolute rock bottom lowest value, and our absolute highest upper bound value. Okay, so what do I mean by that? What I mean by that is if we're going to figure out if something's an outlier or not, we need to have some kind of a parameter to judge that. Right? So the first thing that we want to do is we want to consider what is the least possible number that we're willing to consider that could be included in our data values. So how we would do that is to take Q1, our Q1 value, subtract off 1.5 times our interquartile range. To figure out the absolute highest number that we are willing to consider in our data values is to take Q3 plus 1.5, once again, times our interquartile range. So let's look at some examples that deal with this. Okay, so an example of an outlier. In the 2002-2003 American League Championship Series, the New York Yankees scored the following number of runs against the Boston Red Sox, right? And we have a huge list of data here. All right. Identify the outlier and describe how it affects the mean and the standard deviation. Okay, so before I actually go to calculate this, I want to put this, before I can describe how it affects the mean and the standard deviation, I want to identify what number could actually be an outlier. Do we even have one, right? Well, in order to do that, we want to consider what's called the lower bound numbers, okay? Our lower bound numbers, and we want to consider our upper bound number. All right, so remember to consider our lower bound, that's going to be Q1 minus 1.5 times our IQR. And our upper bound is going to be Q3 plus 1.5 times the IQR. All right, so in order to figure out what Q1 and Q3 is, we need to put this data into our calculator. So go to your calculator, hit your stat button, hit enter. We want to go up and clear out what's in L1. Go back down and input your new data. So 2, enter, 6, enter, 4, enter, 2, enter, 4, enter, 6, enter, 6, enter, 10, enter, 3, enter, 19, enter, 4, enter, 4, enter, 2, enter, 3, enter. Okay, what I end up seeing when I go to calc, my 1-bar stats, I see that my Q1 is 3. Okay, so Q1 is 3. So 3 minus 1.5 times my IQR. Well, I don't know what my IQR is yet. I know that my Q3 value is 6. So I'm going to go ahead and fill this in here. Plus 1.5 times. Remember, your IQR is equal to Q3 minus Q1. So 6 minus 3, which gives us 3. So in both of these parentheses, I can put in the number 3. And I'm going to go ahead and evaluate. I'm going to change colors. That way we can kind of see what I'm working with here. Let's use pink. Okay, so 3 minus 1.5 times 3 is negative 1.5. So that's my lower bound value. My upper bound value is going to be 6 plus 9, which is 15. So what this is telling me is any data values that are less than 1.5 or greater than 15 are going to be considered outliers, right? Well, obviously, I have no data values that are less than negative 1.5. However, I do have a data value that is greater than 19, greater than 15, and that is the number 19. So the outlier is number 19. Okay, now if we want to describe how it affects the mean and the standard deviation, let's look to our next slide. So let's just look at our data. If we keep the outlier in, right, as it stands, so all the data values in our calculator, this is what we end up seeing, right? So we get the mean is 5.357, etc. We see that we have a standard deviation of 4.319. If we take out the outlier of 19, this is the data that occurs there, okay? So if I went back to my L1, I took out 19, and instead of having 14 data values in there, I now have 13. Here's what happens. What happens is that my mean now changes and goes from 5.3 to 4.3. And my standard deviation here goes from 4.3 to 2.16. What's interesting about this is this. When the outlier is eliminated, the mean is actually closer to the median, as well as the number for the standard deviation is smaller, right? So if the number for the standard deviation is smaller, that means our data values are clustered more about our measures of central tendency, right? The mean, median, and mode. All right, so now let's talk about something called expected value. Expected value. All right, so when we're talking about expected value, what this means is the weighted average of the possible outcomes. Okay, so is the weighted average of all the possible outcomes. All right, so if I have the number of accidents n as 0, the probability of that number of accidents occurring is 0.75. The probability of one accident occurring is 0.15. 2 accidents occurring would be 0.08, and 3 accidents occurring is 0.02. So if the expected value is the probability of an event multiplied by the amount of times the event happens, then what I want to consider is this. If my probability of having 0 accidents is 0.75, then I can figure out the expected value of the total number of accidents, right? Or I can essentially sum up this data that I see above by taking 0.75, which is my probability, multiplying it by the number of occurrences, which is 0, plus 0.15 times the number of occurrences, which is 1, plus 0.08 times the number of occurrences, which is 2, plus 0.02 times the number of occurrences, which is 3. Okay, so when we're talking about expected value, what we're really talking about is the sum of the probability times the number of occurrences or values in our data. So adding all of these together, what we end up getting is 0.37. So the expected value for this data chart above has a probability of 0.37. All right, so this is going to be our last example for today. So we want to use the data set for numbers 1 through 3. Okay, so that's our data. We want to, number 1, make a box and whisker plot of the data. All right, so we can go ahead and do that. But before we make the box and whisker plot of the data, we want to input this information into our calculator so that we can figure out our 5-number summary, because that's important. So hit your stat button, enter, go enter up into L1 and clear that. And then go down and let's input our data value. So 9, enter, 4, enter, 7, enter, 8, enter, 5, enter, 8, enter, 24, enter, 5, enter. Okay, now hit stat, over to calc, enter, 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 enter. And what we end up seeing here is that our median, if we scroll down, is 7.5. So I'm going to put that data value right here. Okay, our data value is 7.5. I can see that maybe I'll go up by, we'll go ahead and just put all of our 5-number summary here. Our minimum here is 4. We know that our Q1 is 5 per our data, right, on our calculator. Our median is 7.5. And Q3 is 8.5, and our max is 24. Okay, so looking here, I have my median here listed at 7.5. My Q3 is 8.5. So if I'm going to go up by 0.5-ish here, obviously 24 is way out here at the end. We'll stick 24 right here. Okay, so 24 is here. My minimum is 4. I can see that my Q1 is located at 5. So maybe somewhere around here-ish. My Q3 is located at 8.5, so maybe somewhere around here-ish. Y'all just ignore my tick marks because they're not evenly spaced for this problem. I'm going to go ahead and note here my median. Remember, these two get connected, and then a box gets drawn. Yeah, so ignore my tick marks on this problem, guys. They're not evenly spaced. Just don't draw the tick marks when you do it. All right. So the next thing that I want to do, I want to number 2, so this was number 1, right? Number 2, I want to find the interquartile range. So I want to take Q3, I want to subtract off Q1 to find my interquartile range. So 8.5 minus 5 is going to yield, you guessed it, 3.5 for your interquartile range. That should be an equal sign. Okay, number 3 says find the variance and the standard deviation of the data set. So find the variance and the standard deviation. All right, so the first thing that I'm actually going to find here is the standard deviation, right? And that's noted by sigma x in our data. So if I look at sigma x, it's 5.9948 about. So 5.9948. If I'm looking to find the variance, that's actually going to be sigma x squared. Okay, now if you put into your calculator 5.9948 and you square it, you're going to be off a little bit with your data. And the reason why is because, remember, we rounded, and we don't want to use a rounded number to figure out our variance. So here's what you're going to do. You're going to hit your VARS button, VARS, hit number 5, and then go down to number 4. So put 4 or scroll down to 4 and hit enter. And then we want to square that value and then hit enter again. And what we see is that our variance ends up being 35.9475. Okay, so that's our variance. The next question, question 4, says, are there any outliers in the data set? Well, remember what we did a couple problems ago. If we're going to try and figure out if there's an outlier in this data set, I want to figure out my lowest possible value that I'm willing to consider in my data and my highest. So with my lower, I'm going to take my Q1, I'm going to subtract off 1.5 times my interquartile range, which is 3.5, and I end up getting negative 0.25. And for my upper, I'm going to take my Q3, which is 8.3. I'm going to add to that 1.5 times 3.5, which is my interquartile range once again, and that gives me 13.55. So in order for my data to be considered an outlier, or any of my data points to be considered an outlier, they need to either be less than negative 0.25 or greater than 13.55. Well, obviously I have no data values, right, that are less than negative 0.25. However, I do have one that's greater than 13.55, and that is 24. So 24 is the outlier of this data set. All right, so I hope that was helpful. I know this lesson was a little long. My apologies. Hope y'all are having a great week, and we will see you soon.